Hello Physical Science, welcome back. This is Mr. B, and we are going to finish up section 2. If you remember in our last video, we talked about physical properties, and we listed them all, things like viscosity, malleability, density, hold on, trying to update my computer. Okay, and things like that. And so what we're going to look at today, so we identified them last time, and what we're going to look at in this video is why we actually need to know what those physical properties are, why do we care about them, and also how they can be useful to us. So our first question that we're going to ask is, how can knowing the physical properties of matter be useful? So again, there has to be a reason why we know if an object has a certain density, or if it's malleable, or if it's a good conductor of electricity. There has to be a reason why. So the reason why we want to know those physical properties is because they can be used to identify material, to choose a material for a specific purpose, or to separate the substances in a mixture. So that is really important. There are practical uses for knowing what the physical properties of the material are. First one being, again, if we can actually tell what something is if we know its physical properties. So we can, if it's a good conductor, then we know it's not going to probably be glass, if you remember from our example in class. So things like that, and to use a material for a specific purpose. So again, we're not going to use like plastic wire for our houses, because plastic isn't going to be a good conductor. We want to use copper wire because we know that one of its physical properties is that it's a conductor. Or we can use them to separate the substances in a mixture. So sometimes substances in a mixture, the particles cannot be separated really easily, so we can use the physical properties to separate them, and we will give examples of those as we go on here. But we're going to start with the first one of why physical properties are useful, because they can be used to identify a material. So a material can be identified by its properties. So that's pretty simple. So first off, we just have to decide which properties to test, and we do test on a sample of the unknown material. So let's say we're testing for malleability, so we take our unknown material and we smack it around with a hammer, and we notice, oh wow, it flattens out really nicely into sheets, and so we compare those results with the data reported for known materials. So if we think we either have copper, or we think we maybe have bronze or something like that, and we are able to smash it out, and we can just look and see at the results that people have gotten, and then that might help us figure out what our actual material is. So physical properties can be used to identify materials. And the next one, this is probably one of the biggest ones, is that properties can determine which materials are chosen for which uses. So this is really important. Okay, and the example they give is that shoelaces must be flexible, that is, they must be able to bend without breaking. So they must also be durable, that is, they must be able to withstand repeated use. So when you choose material for a shoelace, you're not going to want to pick something that's really rigid, that can't really move too much, that's going to be kind of, again, if it gets stepped on, maybe it'll break. So you have to find something that is flexible and durable. So what would be a good material, again, using its physical properties, that is both flexible and durable? So that is a really practical use for knowing those physical properties. They can actually help us determine what characteristics we're looking for in order to carry out the job that we need. So the example, our laces in our hiking boots then are usually made of nylon or leather, which hopefully you've probably seen that before. Again, that material right there. And they're not going to be made from wood. So hopefully, again, it's kind of just common sense in this example, but again, physical properties can be because they can help us determine what materials to use for a certain job and what the best materials for that is going to be. So again, those are two ways for physical properties, and now we can use our physical properties also, if you remember, to separate out mixtures. So we're going to look at two processes that use physical properties to separate mixtures, and these are called filtration and distillation. So we're going to get a definition of both of those, so I would jot those definitions down when they come, but maybe be on the lookout for those. So you can separate hot tea from loose tea leaves by pouring the mixture through a strainer. So that's our example here of something that's called filtration, which is the process that separates materials based on the size of their particles. So this is a pretty simple process of separating out a mixture, separating the smaller particles from the larger particles. And the example they give is, again, if you use fresh tea leaves to make tea, you pour them through a strainer, all of your liquid goes out the bottom, and you keep your leaves separate. So that is filtration. And we have another example. Again, these students down here are filtering or sifting dirt through a wire screen to locate small objects. The particles of dirt are small enough to pass through the holes, but objects such as broken bits of pottery are too large. So filtration is a pretty simple process. It usually involves some type of screen, some type of little filter. It has small holes to allow smaller materials to pass through, and then the larger materials will be stuck, and we will be able to separate our mixture. However, we're not going to be able to do that with every single mixture that we have, because sometimes all the particles in a solution are small enough to let me start over here. So sometimes all of the particles in a solution are small enough to pass through a filter, meaning if we have that, again, let's say we want to separate sugar from the hot tea that we made. Everything that we are going to pour over that filter, they're all just going to pass through. The sugar is small enough to where it's not going to get caught in the filter. So this is where we would use a process that is called distillation. And so I'd make sure I write this down. And this is a process that separates the substances in a solution based on their boiling points. So what you do in distillation basically is you heat up a material, and based on, again, remember we learned earlier on that a physical property is boiling point, so different substances have different boiling points. So if we have water and sugar that are dissolved together, if we put it through a process of distillation, when the water boils, all the water will go out and separate, and it's going to take longer for the sugar. The sugar has to boil at a hotter temperature, so then it will remove the water and we will be left with the sugar. So that is basically how distillation works. It's separating substances based on their boiling points. And okay, so I think that's all about distillation. So now we're just talking about, again, just wrapping up physical changes, how we can actually tell when a physical change occurs, because we've talked about physical properties now. So the change of water from liquid to a gas during boiling point is what we call physical change, and this occurs when some of the properties of the material change, but the substances in the material remain the same. So that is a physical change. I would definitely make sure I wrote this down. It occurs when some of the properties of a material change, but the substances in the material remain the same. So for an example, is during a physical change, our size and our shape of material can change, but not the composition. So if we can break things in half, that's just a physical change. We are changing the size, but at a molecular level or at the atomic level, they stay the same. So some examples are melting butter in a pan. Again, all the same materials there, it just has changed from kind of almost like a solidy state to a liquid state. Crumpling a piece of paper, again, we've kind of changed the density a little bit there. We've made it more dense, but that paper still is the same on a chemical level. And then slicing a tomato. So again, we can go from multiple pieces to one piece, but we still have not changed the chemical composition of that tomato. So we'll probably do a little more practice with recognizing the difference between physical changes, and when we get into our next chapter, our next section here about chemical changes. And to wrap it up here, some but not all physical changes can be reversed. So braiding hair is a reversible physical change. Again, we're changing the way the hair looks, we're changing in its appearance, it's just its physical properties, but we're not actually changing the composition of the hair. But cutting hair, however, is a physical change, and it cannot be reversed. And you're not going to be able to reattach your hair to your head after you get it cut off. So both of those are physical change, but again, being able to reverse is only a characteristic of some, where others cannot. So that is it for section 2. Let me know if you have any questions.